All right, in our study of straight lines, up to now, we have looked at problems where there was just only one line under consideration. In this video, we're going to look at the case where we have got two lines. So suppose we have two lines, straight lines on the XY plane. Now, in terms of their orientation, there are going to be three possibilities. There are three possibilities. So the first case is that these two lines could be parallel. So that is the first case. We have got two parallel lines. The second case is that our two lines could be perpendicular. So typically what we're going to do is we're going to call this line L1 and this line L2. So in this case, L1 and L2 intersect at 90 degrees. So we say these lines are perpendicular. In the first case, where the two lines are parallel, they never intersect. And then the last case is the case of two lines that intersect at an angle different from 90, and these lines are called oblique. So so these are the three cases. Now so algebraically, so given two straight lines with gradient. So suppose the gradient of the one line is m1 and the gradient of the other one is m2 respectively. Then if m1 is equal to m2, then the lines are parallel. m1 is equal to m2, the lines are parallel. So like in this case, you can see that the lines are going to have the same gradient. In the other possibility, if m1 times m2 is -1, then the lines are perpendicular, which means they intersect at an angle of 90 degrees right angle. Now if neither m1 is equal to m2, no, m1 times m2 is equal to -1, then the lines are said to be oblique. So we're going to say here, otherwise the lines are oblique. Right, so that is the theoretical side of things. So let's now look at some examples. All right, in these examples, we're going to be given a pair of straight lines Then we are going to determine whether they are parallel, perpendicular, or oblique. Then where applicable, so where the lines intersect, we're going to find the point of intersection and the angle of intersection. So remember, this is the criterion to use to check if lines are parallel, perpendicular, or oblique. So let's get on then. In question A, we've got 4x minus y equal to -9, and 3x minus 8y equal to -14. So 4x minus y, -9, 3x minus 8y equal to -14. Now, in order for us to determine if the straight lines are parallel, perpendicular, or oblique, we need to find their gradient. So what I'm going to do is let's label this equation 1 and this one equation 2. Now we can only read out the gradient if the line is in standard form. Okay, so what we're going to do is we're going to have to convert each of these two lines into standard form. If you're not up to speed with standard form, please do check our videos on the equation of the straight line. So convert this into standard form. Equation 1, make y the subject of the formula, is going to be -9 minus 4x, which is the take the 4x to the other side. Actually, sorry, that is a mistake. It's actually going to be 9 plus 4x. So what we do is I simply take this y to this side and bring the 9 across. So what this is telling us is that M1, gradient for this line, is 4. The gradient is 4. It means the line is going to be upper sloping. Again, check our video on straight line equations if you're not sure how that works out. C is going to be 9. I'm calling it C1 because that is for the first line. The second line, if we make y the subject of the formula, we are going to have 3 over 8x plus 7 over 4. So this tells us that M2 is 3 over 8. So again, that is saying to us the line is also sloping. And then C2, which is the y-intercept, is 7 over 4. Okay, so the next thing we need to do is to check the product M1 times M2. M1 is 4, M2 is 3 over 8. So this is going to be 3 over 2. It's not equal to -1. So that means the lines are not perpendicular. M1 is not equal to M2. So the lines are not parallel. They are not perpendicular. So the lines are oblique. So we say therefore L1 and L2 oblique. If the lines are oblique, it means they are going to have an intersection. So what we are going to do is we can find the point of intersection. So let's do that here, point of intersection. So what that is going to involve is solving two simultaneous equations. Okay, so there is your equation 1, there is your equation 2. However, we've already made y the subject of the formula here, so we can simply take this and plug it in equation 2. So that's exactly what we're going to do. Substitute into equation number 2. Then what we're going to have is 3x minus 2 times 4x plus 9 is equal to negative 14. So all we have done is we have taken this and we have substituted, we have plugged it in there, and then now we've got an equation of x only. So 3x so 3x minus 8x, just one moment. Yeah, there's an error there. That should be 8. So this is 8 here. So this is going to be 32. X minus 72 equal to negative 14. 3x minus 32x is negative 29x. If you take the 72 to the other side, it's going to be 72 minus 14, which is going to be 58. So what this is telling us is that x is going to be negative 2. Then if we take that negative 2 and plug it into this equation here, so y is going to be, we have 9 plus 4x, so 9 plus 4 times negative 2 is going to be 9 minus 8. It's going to be 1. So what this thing is telling us is that negative 2, 1 is the point of intersection. All right, now we need to go to the angle of intersection. For the angle of intersection, we need to make a sketch. For the sketch, the C and the M values are going to help us. So let's start with this one. For instance, this is upsloping. C is 9. Okay, so what we're going to have is something like this. So C is 9, and this is upsloping. So M is 4, so that could be our L1. And then for the other line, C is 7 over 4, which is less than 9, and M is 3 over 8. So this gradient is smaller than that one, so that means this line is like this line is going to be a bit like that. Okay, so the situation is going to be something like this. Okay, that's L2. Remember, for L1 M is 4, for L2 M is 3/8. Okay, so 3/8 there. Now the angle of intersection is this one. So remember, this angle is going to be the same as that angle. There's going to be another angle here, so we can either find this angle here or we can find this angle here. I'm going to go for this one. So the thing that we're going to use here are the inclination angles of the two lines. So for M1, for instance, so let's call this one theta 1, this one theta 2. So theta 1 is going to be inverse tangent of 4, which we can punch in the calculator, but I am not going to. Okay, well, maybe let's do. So this is inverse tangent 4, so cancel this off. Inverse tangent 4 is 75.96. So okay, maybe let me write that one here. So this is 75.96, but I'm just going to keep this one in mind. And then theta 2 is going to be inverse tangent 3/8. Again, we can punch that in the calculator. So inverse tangent 3/8, 8. So this one is going to be 20.56. So 20.56. So that means we can find this angle now, because from this we can find this angle there. So that angle is going to be 180 minus 75 on 9 on 6. And then using this triangle here, we know that this angle plus this angle, this angle plus this angle plus that angle, they must add up to 180. Okay, so if we do if we do 180 minus 75.96, 96, so in degrees it's going to be 104.04. so this angle here, 104.04 degrees. So theta plus 26.56 plus 104.04 is equal to 180 degrees. So theta is 180 degrees minus the sum of these two, 56 plus 104.04. So theta is going to be, we can punch this in the calculator, So this is going to be 180 minus 26.56 plus 104.04 04 equal. So again, so in degrees that's going to be in decimal, it's going to be 49.4. So our angle of intersection is 49.4. Now I'm going to show you something. Notice what happens when we do theta 1 minus theta 2, just using those ones. Okay, so let's just do that in the calculator. So we want to do inverse tangent 4 take away inverse tangent 3/8. Okay, and we get 55.4, which suggests that there is an error, because that should be the same as this one. So let me just check where the issue is. Okay, sorry, there's an error here. This angle here is 20.56, not 26. Sorry, couldn't read my own handwriting there. So this is 20.56, 20.56, and so this is going to change. So let's do the calculation again. So it's 180 minus, open brackets, 20.56 plus 104.04, and that angle in degrees is 55.4. So this is 55.4. So I was just showing you that basically that is just the difference between these two angles here. This one, since 4 is bigger than 3/8, so this one is going to be bigger. So if you just do the difference of those two, it gives you the intersection angle. We will talk about how to see that in general when we round this up. But look, inverse tangent of 4 minus inverse tangent of 3/8 is 55.4. So we could have done this whole thing by just subtracting those two, but you need to do this with understanding, and we will bring that understanding into the fore when we summarize this section. All right, so let's go now to example number B. As you can see, these examples are a bit involving, so you need to take your time. In B, we have got 4x minus 6y equal to 7. The other line is 3y minus 2x is equal to 4. Call this L1 and call this L2. So what we're going to do again is we're going to make y the subject of the formula in both of the lines. Okay, so for L1, y is going to be equal to 4/6x minus 7/6. 4/6 is 2/3. minus 7 over 6. So that means M1 is 2/3 and C1 is negative 7 over 6. Then we do the same thing for Y2, L2. So in that case, we're going to have 2/3 x plus 4 over 3. So that means M2 is 2/3 and C2 is 4/3. Now notice that M1 and M2 are exactly the same. M1 is equal to M2. This is implying that the lines are parallel. If the lines are parallel, there is no point of intersection, and no angle of intersection as well, because there is no intersection. Okay, we're going to do just one more example. So C, so let's now go to example number C. In C we have got 3x minus 4y equal 18. Then 4x plus 3y is negative 9. So we have, so that's L1, 3x. Yes, 3x minus 4y equal to 18. L2 is 4x plus 3y equal to negative 1. Expressing these in standard form, first one is going to give us y equals to 3 on 4 x minus 9 over 2. So this tells us that M1 is 3 over 4, C1 is minus 9 over 2. L2, make y the subject of the formula there. It's going to be minus 4/3 x minus 1 over 3. So that tells us that M2 is minus 4/3 and C2 is minus 1/3. Excuse me. From which clearly these two are not equal. But the next thing we need to check is whether this product is equal to negative 1. And from this you can see that this product is negative 1. So this is telling us that L1 and L2 are perpendicular. If the perpendicular, then the angle of intersection is already determined, is the angle of intersection. So all that we need to do now is to find the point of intersection. What we can do is we can take, because we have already made y the subject of the formula, or maybe this time what we're going to do is we're going to use the method of elimination. So what we're going to do is we're going to take this and this equation multiplied by 3, take this equation multiplied by 4, and then eliminate y. So that's the point of intersection. Okay, so if we take L1 and multiply it by 3, we are going to have 9x minus 12y is equals to 54. Take L2 and multiply it by 4, we're going to have 16x plus 12y is equals to negative 4. If we add this is going to be 25x. This is going to be 50. So that tells us that x is going to be 2. Then if we plug this into any of the y equations, could plug it here, for instance. So remember, x is 2. So y is going to be 3 over 4 times 2 minus 9 over 2 is going to be 3 over 2 minus 9 over 2 is minus 6 over 2. So y is going to be minus 3. So 2 minus 3 is going to be the point of intersection. Alright, so this time, because the angle was determined simply from this analysis, we did not have to do a sketch. Alright, so that's A, B, and C. We are now going to ask you to do from D to G. So if you want to have a go at D, E, F, and G, then you will find our working out of these in the next video, which is going to be part 2 of the parallel, perpendicular, and oblique lines. Alright, so hopefully this has been useful. Thank you for watching. Please do subscribe to support this channel, and so that you can get notified whenever we post new material.